Hello everyone, good evening to all. Today I am going to solve a question on status 125. The question is binary minimal. Here the question says you have given a binary string s of length n. You can perform the following operation on string s. The operations are: the first operation, select an index I and you can delete the character at that particular index. Then the second type of operation is you can select an index I and flip the character. If the character is 1, you can flip to 0. If the character is 0, you can flip to 1. Here the vice versa can be possible. Then after performing the above operations, you have to find the lexicographically smallest string that you can obtain by using at most k operations. In the input, you have given n and k. N is the size of the string and k is the maximum number of operations. And the next line of input is the string containing length n. Here in case 3 1, the string is 0 0 0. In this case, you can apply first operation, that which is select an index and delete the element and at that particular index. So the number of operation is 1, so you can delete the first 0. Then it will be lexicographically smallest string. Then in the case of 2 0, there you cannot perform any number of operation because k is 0. Here in the question, you have given n, k, n is the size of the array, k is the number of operation you can perform, n is the size of the string you can given 1 1 0 0. If you are given 3 2 1 0 1, then you can perform two operations. You can delete 2 element, then this gives a 1, and you can flip the elements like 0 1 1, which is lexicographically smallest. You have to find this string which is lexicographically smallest after performing the k operations, at most k operations. So in this question, you can always think that there is no need of performing second operation, which is flip the character at that index only. Flip 1 to 0 0 to 1. You think that this operation is to find the lexicographical smallest. If we don't apply this, then we always find the lexicographical smallest. Suppose like if 1 1 0 1 1 5 3, then you can simply delete this, then this will be string. If you apply the second operation at least one time, then here the length is 2, but here the length can be 0 1 1. Here the length can be 0 1 1 0 1 1 1 1. So you can think that there is no need of applying the second operation, but this is the wrong. That in the case if 7 3 1 0 1 0 1 0 0 1 0 1 0 0. In this case, if you apply only first operation, then this gives 0 0 0 1. If you apply the both operations, then 0 0 0 0 0 0 1. Here this is lexicographically smallest. Lexicographically smallest than this string, because here the difference, the first difference indices have 0 in this case but 1 in this case. In the question he says that the lexicographically smallest number is the string in a string if there is two string S and T. If the first distinct element index, if the which contain the, if this is this in this two string, the lexicographically smallest string is that string which contain, suppose the first index, we have to find the first index which contain different element. If the element is which string contain the smaller element, this will going to be lexicographically smallest element. So in this case you can fail your result, but you have to take this, you have to consider this test case, then only you can pass all the test cases. So now run the code. So to apply the both conditions optimally, you can count the number of ones. If number of ones less than k, then you perform delete operation k times. First one delete, then if there is remaining k, then delete the zeros. Else if ones more than k, if the number of ones is more than 1, then you simply swap the k ones to 0, then add remaining. This is our algorithm for this question. So let's come to the coding part. Here I write the same thing which I explained in the pen and paper. First I calculate the number of zeros and number of ones in that particular string. Here the number of zeros is C and number of ones in C1. If C1 less than equal to K, then I simply swap the indices. If else, then I replace 1 with 0. Here I print S1 if number of ones is less than equal to K. In this case, if C1 is less than equal to K, I simply perform the delete operation on that string. But in this case, I replace 1 with 0. So here I print S1, here I print SB. Then I going to run the code. I think this will okay. Yes, 0011. This gives right answer. Now I am going to submit the code. I think this will get accepted. Let's see. Yes, it will got accepted. Thanks.